In this session, I'm going to prove the quotient rule for differentiation. And the quotient rule is the derivative with respect to x of the quotient of two differentiable functions f of x divided by g of x is g of x f prime of x minus f of x g prime of x over g of x squared. So just as we did with several other derivative proofs in this series, we're going to use the limit definition of derivative to prove this one. So let's begin the limit as delta x approaches 0 of f of x plus delta x over g of x plus delta x minus f of x over g of x all over delta x. Now we need to combine the terms in the numerator to get a rational expression with a common denominator. So g of x times f of x plus delta x times f of x plus delta x, and then this times this using that sign, minus f of x times g of x plus delta x all over this times this, g of x times g of x plus delta x. And that whole thing, since this whole thing is being divided by delta x, that expression is actually delta x over 1. We can change this operation to multiplication simply by inverting, taking the reciprocal of the denominator. So this is actually the same as multiplying by 1 over delta x. So this is being changed to that. And that means if this is being multiplied by 1 over delta x, the delta x comes over here. Okay. Now, in this statement, we're going to have to manipulate this numerator because we're going to need to group terms in a specific way to create new terms. And we're going to employ a technique similar to the one we employed in the product rule proof, in which we're going to subtract and add the same quantity into the numerator. In this case, the quantity that we're going to put back is going to be, let's go ahead and rewrite the first couple of terms, x f of x plus delta x, and the term I'm going to subtract in, I'm going to put in a different color, and we're going to subtract out f of x times g of x, and then we're going to add that back in, plus f of x g of x, and then we're going to copy this down. Let's go back to our original color, minus f of x g of x plus delta x, and this whole thing is going to be over the same delta x g of x g of x plus delta x. Okay, now let's give ourselves a little room down here because we're getting a little tight on space. And the key to moving further with this process is we need to be able to group some terms over here and the denominator terms in just such a way that creates some limit definitions of derivatives. Now, if you see here with this first pair of terms that we subtracted in, that we can factor out a g of x, and we're going to have an f of x plus delta x minus f of x left over, which when divided by delta x gives us the start of the difference quotient. When we take the limit as delta x approaches 0, that gives us the f prime of x. So that's our first grouping that we're going to do. So we're going to go ahead and we're going to say factor out a g of x, and what we have left is f of x plus delta x times the negative f of x over there, and we're going to put that quantity over delta x, and then we'll group these terms. And in this grouping, we can factor out an f of x on this side. So let's factor out, and actually, if we factor out a negative f of x, we will have, here, we'll have, this becomes positive, so we have g of x plus delta x. This goes negative, minus g of x. We'll put this quantity all over delta x as well, because we're dividing by this entire quantity. And then the remaining part, this part over here, we're going to slide all the way off to the side, and we're just going to multiply this whole quantity by 1 over that quantity. So this is 1 over g of x, g of x plus delta x. Alright. Now we continue to carry down our limits, and when we take the limit as delta x approaches 0 of these functions, what we have is the limit as delta x approaches 0 of g of x is simply g of x. And the limit as delta x approaches 0 of this quantity is our familiar f prime of x. And the limit as delta x approaches 0 of this quantity is simply f of x, so minus f of x. And the limit as delta x, as delta x approaches 0 of this quantity is g prime of x. And the limit of this is going to be, this term is going to go to 0, because as delta x goes to 0, g of x plus delta x is g of x plus 0, which is just g of x. So we'll have 1 over g of x times g of x, which is just 1 over g of x squared. So this is times 1 over g of x squared. Okay. And as a final touch, we'll go ahead and just put this whole thing over g of x squared. So we have g of x f prime of x minus f of x g prime of x over g of x squared. Now, inasmuch as this looks really kind of nasty, we can make our lives a little easier by noting that there's a pattern here. If we call this expression the low expression and this expression the high expression, then the derivative quotient rule becomes a really easy thing to remember. You can say, just as a silly little limerick, equals low d high minus high d low over low squared. So low d high minus high d low over low squared. So here it's low d high, derivative of the high, minus the high function times the derivative of the low function over the low function squared. Any way you want to remember it, this is the quotient rule for differentiation. And I'll see you in the next session.